Example 2, section 4.3. We need to solve an initial value problem. It is convenient to write this second order differential equation, which is homogeneous again, because the right of the equation is 0. So we can write the given equation. We can write the auxiliary equation from the given equation, and in this case, it's going to be r squared plus 16r equal to 0. So this is an equation that can be solved like, well, there is an r here, an extra r. So we can either apply the quadratic formula or just factor, or maybe isolate r squared. So we have r squared equals to negative 16, and then apply a square root on both sides. So we have r equals to positive and negative 4i, right? So the solution is positive and negative 4i. So remember, positive and negative 4i can be written as we don't have any real part. So since we have no real part, this solution is equivalent to 0 plus or minus 4i. Okay, so this solution is complex. This solution is complex. Complex because involve an I. So remember, when the solution is complex, the solution of the differential equation is going to have this form. Y of x equals to e to alpha x c1 cosine of beta x plus c2 sine of beta x. And then the solutions, we can write it like, if we write the solution of the auxiliary equation as alpha plus minus beta I, then we can conclude that alpha is 0 and beta is 4. So the solution of the equation of the ordinary differential equation of second order is going to be e to 0 power is going to be 1. E to 0 times x c1 cosine of 4x plus c2 sine of 4x. Remember, this term is going to be 1. So we have just c1 cosine of 4x plus c2 sine of 4x. And then we are in need to find the solution of the initial value problem. So two conditions are given. Y at 0 is 8. So this is the solution of the differential equation. So trying to solve the initial value problem, one condition is y at 0 equals to 8, right? So we have that 8 is equal to z1 cosine of 4 times 0 plus c2 sine of 4 times 0. This term is 0. Sine of 0 is 0. Cosine of 0 is 1. So c1 is simply 8. Okay. Now is the moment to use the condition of the derivative. Y prime at 0 is negative 1. So we have y prime at 0 is equal to negative 1. Now, to use this condition, we need to find the derivative of the general form. So derivative of the general form, okay, let's specify that this is the general form. General form. Derivative of this is going to be simply negative 4 c1 sine of 4x plus 4c2 cosine of 4x. Then, using the condition, we have -1 equals to -4 times C1 sine of 4 times 0 plus 4C2 cosine of 4 times 0. So, uh, oh, well, the condition is, sorry about that. The condition is, it should be -6. -6. My apologies, -6. Okay. So we have sine of 4 times 0. This term goes to 0, right? And then this term is going to be 1. So C2, so we have -6 equals to 4C2. Isolating C2, C2 is -6 divided by 4, which is equivalent to -3/2. So the solution to this problem, the solution to the initial value problem is C1, which is 8 cosine of 4x plus C2, but C2 is -3/2 sine of 4x. And this concludes the problem and solution of the initial value problem.